Hello and welcome back to Tetris. Today, after following up after our unit testing and stuff, I wanted to add the next pretty major feature in this. I will update that later, and that's going to be the beginnings of our collision detection. And so, currently, as it stands now, we have this little web thing here. We can press the letter N, we get a block, we can move it. But as you guys saw, if I go off the screen, it changes from giving me normal ticks to errors. And then yes, I can pop back on, but we want it to not be able to go off the screen. So there's going to be a lot of math. We're going to have to figure out a lot of things. We're going to add some new methods. We might add unit tests to them. We might get to that next time, or we could start with the unit tests. Maybe let's try that. Let's try allowing the unit tests to drive our design, switching into the mode of TDD where we write a test, allow it to fail, and then we start actually writing the code that makes that test pass, as well as giving us the functionality that we want. One of the advantages to that is that you kind of start to become a little more expressive, and you start really telling your your objects what what you kind of want that to do. So let's see, a couple things we need, right? So let's look at our models, and we need to figure out what are some of these things that we need. And again, I haven't really planned this out. I just kind of decided, oh, I'm going to do Tetris, and oh, let's figure out collision detection. So here's me figuring it out. One of the other things I noticed rewatching some of the old videos is I have new board up here, which sets it to the wrong thing, and then I load in index and I set it to the right thing, and it overwrites the one that's in engine. And while that's convenient, it's wrong, and I don't like to have bad and wrong code anywhere. So we're just going to put this in here where it actually belongs. And now let's turn that off. Okay. And now it actually starts, correctly, hopefully correctly working. So we're just going to confirm we didn't break anything. We still get a board. We still can move the blocks around. That's another thing we need to get to, is disabling the up and down functions of that. So we will get to that, and probably by figuring out some way of sizing this to match within the window. Not quite sure how to do that, but we'll get to that. Okay, so what do we need to do here? We need to figure out how are we going to implement our collision detection. As soon as I figure that out, we're going to start writing tests. Okay, so we have a board, and a board has an area which is the box, and it has a bunch of rows and columns. So I've got rows and I've got columns. What I'd kind of like to see is I would kind of like to see the creation of let's see, like bounds. So what's the best? We kind of want to define ranges, and so we want like self dot bounds. I'm just stubbing this out to kind of like figure out, do I want, because I could do something like max and have that be an object with an x, and then a y, and then have a min, and that has an x and a y. Which I know some of you are like, why do we need a min? Because we have a, we know that the minimum is 0. Well, in case we ever want to change that design, trying to like, properly set this. So I'm thinking, yeah, let's do that. So we're going to do bounds with a max x and a max y. So currently this is going to fail. So I'll comment this out because we're gonna come back to that later, and then we'll go into our models. And we have block and we have shape. So what we need to do is we're going to describe board and give it a function, and we're going to say that it expects board. Well, I guess we need to pull in a new board, right? So we're going to do var board equals a new board, and then we're going to give it an empty JSON or JavaScript object, jQuery object, because this needs to be unit testable, which means that it needs to have something that it's not dependent on the JavaScript or the HTML that's already on the page. So we're just going to create a brand new div, and then we're going to add our 20 rows and 10 columns. Alright, so that'll be our board, and so then we need to do expects board dot bounds and to or not to be null. Okay, so if we run this, so that's karma start. We're going to start running our tests, and we should see that it fails. And it says expects is not defined. Oh, it. That's right. I need to do it and has bounds and function, and then move the expect statement to inside of there. Save that, and expects is not defined. Executed what? Changed file, specs, board has bounds, failed. Oh, probably because literally this is undefined. So, okay, well let's go into our model, and we're going to add bounds, and we're just going to set it equal to an empty object at the moment. Okay, so it's still undefined, which is strange. Something's wrong. Expects is not a real word, it's expect. Okay, so now we have a success. So we'll just confirm the TDD, and we will comment this out, run the test, and it's successful. That's not good. To not be null. Can we make a change, save? Okay. So that's not good. That's not a good test. Expect board.bounds not to be null. And then, well, how about we'll do expect board.bounds not to be undefined. Alright, there we go. So undefined not to be undefined. So we do in fact have an issue there. So we don't want it to be undefined, and we don't want it to be null. And then when we go back over to our function and we remove these, we save it again, now we get success. Great. So we're starting to get there. So we will say that I think we can do another describe inside of here. Describe, and we'll do board bounds, give it a function, and we'll say it has a max function, and only do one at a time when you're doing TDD. So we'll do expect board dot bounds dot max dot not to be undefined. Run that, fails. And then we've come back over here and we're going to add a max to this, and we're going to set that, max, and we're going to set that equal to an empty object at the moment to make the test pass. Flip back over, and we will then say it has a min, give it a function, and expect board.bounds.min not to be undefined. Okay. Missing semicolon. We'll run that again, and it fails. Flip back over, and now we're going to define a min with an empty object. And then, so then we'll describe, try to shorthand this as much as I can, describe board bounds max, and we'll stub out two of these. Just trying to speed this along a little bit. TDD can be a little, it can be a little slow and take a little bit longer, but when errors happen, you'll catch it a lot faster. So that's good. So board bounds max has an x and has a y. So board bound max dot x and dot y. Okay, save that. We get 2 failed. Flip back over to the model, and now we're going to set a y equal to x equal to 0 and a y equal to 0. Run that, and we still get undefined. So we need to figure out why, because it needs to be max. Run that, we get success. We'll copy this whole thing, and drop that down here, and we'll say min and min and min. Run that, get 2 failed, flip back over to models. Now we get y 0 and x 0 and then y 0. Okay, so now is where we actually start getting into some of like the worth it unit tests, not just, oh well, stuff's missing, but we actually set the values correctly. So we want our minimum x to be 0, and then we want our minimum y, or sorry, these are maximums. We want the maximum to be the rows, right? X is columns, so cols minus 1, and our rows minus 1. So what that'll give us, and actually what I should have done is I should have done this part first, but the max, we expect board bounds max x to be 19, and then we expect the y, this should be 9, and the y should be 19. Run that, and we get a expected 9 to be 19. Okay, let's look at this again. Oh, here we go. Y. There we go. So now we're actually making sure that based on what we're inputting here, so even if in the game we change the board size to 30 and 100, or whatever we want to change it to, that the unit test will still run because it's using this model here. So despite what we do with our game, we just want to make sure that the logic of it getting set correctly is correct. And then the other thing we want to do is we just want to expect that these are going to be 0, because they should be 0 currently, unless we define the behavior later. So the assumption is that they will be, in fact, 0, and if that ever changes, then that means that we need to change our tests and that we might need to relook at our code, because again, we're assuming that. Okay, so now that we've got some bounds in here, now we need to do block, and we need to do, let's see, we need to do collision detection. So we could place the collision detection in each one of these movements, but then you see that you're duplicating your code. We don't ever really want to duplicate our code. We'd rather figure out another way to do that. So we will add a new method. So we'll back to TDD, right? So we've got board, and it has bounds, and we'll flip back over, or come back over here, and it has, nope, it's not our board. I do want to copy that, but it's not our board that has bound, or has, it's our block, right? So our block, let's say, can detect collisions. Alright, so the first part of this is to actually unit test that it actually has it, right? So expect block dot collide yeah, collide. We'll just call it collide for now. So expect the block.collide to not to be undefined. Alright, flip over, it failed. So then we come back over here and we set ourselves up a self dot collide equals a function that takes in the board. Does it take in the board? Should it take it? It needs to know about the board, and the shape itself does not know about the board. Okay. So I think what we're going to have to do is we're going to have to take some of these functions here. And they're actually going to have to take in a board object. So we'll see how that plays out. But for the moment, we just have now we have a success in our unit test. So we don't want it to be undefined. And we want it to be a function. So expect type of block.collide to equal a function. Okay, and that's also passing. So then we flip back over. So now we've got our collision. So now we need to think about how does this collision actually start working. So basically what we need to do is, if we do so how do we detect a collision? Well, we detect a collision by any piece of the block, which is defined by the shape, plus basically these well, not really. There's a lot that's going to go into this. This method's going to be rather large when we finally get done with it. So I'm going to go ahead and start just writing this out, and then we will find a way to test it and make sure and confirm that it's correct. So we will do. So first thing we want to do is if and we need to find the smallest x. Well, the smallest x is always going to be 0, but let's try to find it programmatically. So if self dot position dot x, so that's our left bottommost block, right? If our left bottommost block is less than our board bounds min x, then we want to return true for the collision, saying yes, we have a collision. So then if self position y, our y may not be correct because we do have some blocks that are our smallest y. Well, it is, we do have a 0 as the smallest y. Do we have any blocks that don't have a 0y? No. All of them do in fact have a 0y. Do we have any blocks without a 0x? Well, obviously not. Okay, so I guess we can go with that, right? We're going to have to do a little more math when we get to this next piece. So we'll do board bounds min y, then return true. And then if, and here's where it gets tricky, so self.position x, well, first we need to find the largest x. So I'm just gonna start going with this, and we'll refactor it down into something a little more condensed. So if max x, or var max x equals self.position.x, well, we need to, yeah, that's what I'm doing. I'm trying to get the maximum x. So for all the shapes, give me the one with the largest x. And how do we, is there a JavaScript, I guess, array function that will help us with this? So max, let's see, get max value in array JavaScript. Largest number contained in an array. Array.max, math.max.apply. It's not de facto until resig blogs it. Fast JavaScript max and min. So function array, return math max apply. Okay, so this is kind of interesting, right? This is basically kind of what we want to do. You just find any built-in JavaScript function that takes unlimited arguments. It'll now be as easy to adapt it for array-wide use by using JavaScript's apply method on the built-in function. You can pass an array of unlimited arguments. Okay, so we're going to give this a shot. So he's doing what? Wait, what was this? So array max. Yeah, we'll probably break that up into other functions. So currently we just need math dot max dot apply math, and then we pass in the array, right? Argument array. So, well, it does look like we kind of need this array max because it looks like it kind of loops around and potentially. So let's do what we need is a self.max equals an object. What I'd like to do is max equals and then give it an x and a y, kind of using the same type syntax that we were using before. So now I can do x is a function which x is not a function. Well, x is equal to well, this is kind of an array extension. This is kind of an extension method. So what I'm going to do is I'm going to throw this directly in the code, and let's actually, well, we'll throw it up here for now, so we can play with it and test it out. And then, yeah, so now we can do, let's do position. Does array have collect? I just thought of something that might really help. Collect MDN for getting the best results. And it has a map, creates a new array with results of calling. Okay, so that's okay. So we're going to use a combination of these things. So we're going to take self dot shape dot what is it? What are coordinates? Dot map, and we'll pass it a function of x, and we'll do x dot, and what does it have? We want to get the maximum x, so we're going to read all of the x's out of this is what we're going to be doing. So x dot x, so that's kind of a terrible name. So we'll say item it will be more helpful. So item, or we could say chord. Let's do that. Chord. That's a little more expressive. Chord. So we will return chord x, and this whole thing then becomes an array, which then we can call max on, and well, actually we just need to do, we can actually do array dot max and pass this whole thing in as the array. Are you guys following? Unexpected token. Oh, because I'm inside of this. So this is, I'm going to have to unit test this because this is getting kind of hairy and I need to make sure that it's actually going to work. So we need the y coordinate for here. And still unexpected token because of this. So we actually want to remove that. We'll just leave that as it is. Log tick, interesting. So now what we're going to do is we need to write a unit test that will confirm that we've got that right. So we've got block, has a shape, has a position, has a color, but it also has a max. So it has a max function, and then we're going to go expect block dot max dot not to be undefined. Run the test. Succeeds. Then expect block. Then we need to say it. Yeah, I'm just gonna do the shorthand. So it has an x, and take that function, pass that in, and now we'll expect that block max x not to be undefined. Save that. Cool. Alright, now the next thing is going to be kind of tricky. So it has an x, yes, but it also has to have the correct value. So in order to do that, we need to set up the test. So max x to be, and let's just put 0, and this should fail, but it doesn't. So slightly concerning, because I would have thought that the max x should in fact be array max Well, we've got, well, even if we have a 0 and a 0 for the shape, right, in our test, 0, 0, and 19, the x is still 0, and then, as we can see, we should not get an x of 0. Okay, well, let's manually test this. Let's go into the browser, right, and we've got our block in here, right? So what is it? Board blocks. Grab the first one. Dot max. Can't read. Shape of undefined. Oh, because we haven't created a new block on the screen yet. Okay, now we should have dot max x of 2 and y of 1. Well, that looks correct, but why was the unit test not being correct? The unit test was not performing, so not actually checking it correctly. So expect block, how about to equal? That's not good. Do I need another describe? Maybe that, I mean, I just have my unit test terribly wrong. Or I can just take it out of here and I'll just confirm this way for the moment. Because I'm not typing a bunch of stuff, and I know that these tests will work. Okay, so now we're getting expected 3 to equal 0. Should it be 3 is the question. So if we have a shape of 0 and its x is 0, then our max should be 3. That is correct. We do in fact have a 3 here. And then our max y should also, well, should be 0, which is kind of bad. So we probably need to flip over to another block in order to test these ones. So what I'm going to do is I'm going to use block number 2 because we have expected results for both y and for x. And I need to, so we're going to flip our unit test over, so we're going to put it at 18 because this one is too tall, and set this, well, that to 0, but this to 1. So now when we run the test, block can move left failed. 17 to 18. Okay, so some of our numbers are kind of off because we switched to a new block. That can happen. So if we move down, it should then become 17. If we move right, it should then become 1 and 17. And if we move to the left, it should be 0 and 17. And 2 failed. Block has max failed. Okay, that's kind of expected. Block has max. X should be what? What was it? 2? Okay, expected coordinates to equal coordinates. Block has a shape failed. Block has a shape. New shape 1. Okay, so now we're back to successes. Great. So we've got a better block that we can test. And because we can now do expect block max y to equal 1. And success. Alright, so now we've got a confirmed working model. Confirmed working bounds and confirmed working max positioning on these blocks. Okay, why did I go through all that? Why did I care about having a max? Well, because we need to know how far right is too far right. For each block, some of them they're more horizontal than they are vertical, and so on and so forth. So we need to actually see, based on their coordinates times their position, or adding their position, are they actually too far to the right? So we take our position x plus our self dot shape coordinates x, or well, actually self dot max x, right? Max x. Now that we've built that, so we add those together, and then all of that must be if it's greater than our board bounds max x, then we're going to consider that a hit as well. So now that returns true. And then if self position y plus self max y greater than board bounds max y, then we're going to return true for that. Now, if none of these conditions get met, that means it didn't collide. So how are we actually going to use this function? So as I said earlier, we're probably going to have to change these, and that is true. So when we move left or we move right or any position of that, we actually need to pass the board in. So now, where did we put that? We put that in our index, right? And now that it's in our index, we don't have an instance of board in this file anymore, or do we? Because the engine gets, nope, we do, because the engine gets loaded ahead of time. So we do have board, and then we just pass the board in. And so now that we're passing the board in, we can pass that into our collision function, and it will tell us if we have collided. So now, if Now when we're moving right and left, we have a board that goes in, B-O-A-R-D. All right, and then if we, okay, so now we can say if self dot collide, then we really just need to return, and we can start returning booleans now. So we'll just say false to kind of give a little bit of feedback, saying, hey, this can't move. And that'll also help our unit testing because we would expect it to be true. So anytime we move down, we expect it to be true. So we're going to return true. And if we can't move because we collided, we are now going to go false. So I also forgot to pass the board in here. Don't forget to do that. So we create the same type of thing here. Return true. And collide, return true. Now there's one thing that we really haven't addressed is this is only going to account for our current, this is only going to account for where we currently are. So this is never actually going to work. You're just going to move right, and then the next time you try to move right, or move down or move left, then the collide is going to fire. So we actually need this to be intelligent, as in which direction this is going to be moving in. So what we need to do is we need to do an x diff and a y diff. Right, so we'll do x diff and y diff. And what this is going to do is, so anytime we see self.position.x, and we'll say plus the x diff. No, I don't want to switch my language. When did you think I would want to switch my language? Okay. And then we'll also add the y diff here. And then we'll pass in the, we need to also add it here. So we'll say plus x diff and plus y diff. Okay, so a lot of adding and stuff going on here. Where is this? Syntax error, line 48 in model. So model line 48 is here. Yep, that's correct. So now we're going to pass in, what do we alter here? We are altering our y. So our x diff is going to be 0, and our y diff is going to be -1, because we are altering the y by -1 in this function. So it's kind of we're telling you ahead of time, hey, this is what's going to happen. And so now we do, we're actually going to do 1 and 0. And then we need to do -1 and 0. Okay, so it's kind of like a future prediction. So we're telling, hey, if I were to do this, this is the difference that I'm going to be making to this. And then the collision can go, okay, let me factor in that difference, and then I'll come out with my result. Okay, so cannot read property bounds of undefined. So something broke our tests, and now we apparently don't have a bounds on our board object, and this is really strange actually. Cannot read property bounds of undefined. Self.collide 74. What is, why not? Where is self.collide board bounds, board bounds, board bounds, board. Well, that's really strange. What? Some of you tested a full page reload. Well, yeah, probably. So we're going to close down Karma, and I'm going to stop this, and we're going to restart it, and just make sure that it's not an issue with something going on here. Nope, 3 are failed. Block can move left, failed. Cannot read property bounds of undefined. Okay, something is going on here now. And that's kind of strange, and we need to figure out why this suddenly broke. Block can move left, failed. So let's look at our tests. Block can move left. Expect block move left to be null. Expect the type of move left to be a function. Still is. Then we call block.move left, and then we expect it to be 0, or we expect it to be 17. Well, we do, because this is a valid legal movement. So something is going on here that's preventing us from making valid legal movements. Because if we collide, okay, so let me confirm we have this right. So if the x plus the x difference is less than, then we're going to return true. Okay, it's time to debug. So we're having some issues. What I'm going to do is I'm going to come over here, and I'm going to press new. Oh, I have to do it up here. Press new to get a new block on the board, and we'll kind of move that around, right? And then I need to do, we need to actually inspect this. So board bounds, board blocks 0. We'll say move left. Cannot read property bounds of undefined. Okay, so there's an issue actually inside of the move left function for whatever reason. So can we do blocks dot collide, and we'll pass it a board and 0 and 0 and just see. Well, that returned undefined, and if we returns undefined. What if we did 2? What if we did 3? Now we headed true. So if we were to go up 3, 1, 2, yep, the third one up would in fact collide. But we don't go up, we go down. Still, so if we go left 3 by going -3 and then 0, we should also get true, which we do. So the calling this with move left versus, because move left is not receiving an argument. Okay, we're getting somewhere. See, our unit tests help show me that I missed something, and that something is, I believe, is it in here where when I'm calling, so what I need to do is open up index.js inside the browser as I'm going through it, and we're going to go to sources, we're going to open index.js, and I'm going to place a thing here, right? Well, not there. We'll place it here, and then I'm going to call, or I'm going to press the left key. Oh, okay, I get it. So what's going on is that the keyboard is in fact passing the argument. The tests are not. Okay, so at least we know what's going on. So we come back over here. Now we're saying move down. We need to pass the board to it. Okay, so now we get 2 failed, 1 failed, and back to green. Great. So now we've got some better stuff going on here. So I had handled the real code, but I didn't handle the tests. That's kind of the nature of the beast. But what we should see is this actually start working. So I'm going to flip back over here. I'm going to refresh, and we're going to press N, put a new block on the board, and press down a couple times, and then I'm going to press left. And you can hear me. I'm pressing left, and nothing's happening. Press right. Great. Press right some more. Nothing happens. If I press down, I can't go outside of the box. So now we have correct collision detecting, as in it knows where I can't go up or down, or down or left or right, because I've now collided. So that's really all it is to collision detection, is you figure out you figure out the math behind stuff, and then you have to do kind of this prediction into the future somewhat. Or sometimes you can detect like another way to do this instead of doing this collide that passes in methods, is that you maybe pass in the direction, or maybe you do a lot of this math up here, but I wanted to not repeat myself. I didn't want to I didn't want to I didn't want to send to repeat myself up here and have all this logic up here again. Like, we want to write these methods that they maybe take some time for us to figure out and work on and do all this stuff. But then, once we implement them, then it's as simple as just calling collide. And we can maybe call this something like did collide or will collide or something like that. I just wanted to call it collide for now. And that should work. So now we've got proper and correct collision detection, and it's expandable for whatever size board we have. So yes, we could have just said, it's greater than 20 or it's greater than 10. But again, what if we wanted to change the size of the board? So what this allows us to do is it gives us the ability to detect what our shape is like and what maximum shape it has, and it also allows us to detect the collision stuff. And this should work for any of the blocks, because we're taking the maximums and the minimums, the maxes and the mins are always going to be they're always going to be 0. So this is a great way to do this. I think that this is probably the best collision detection for this particular scenario. Of course, this can all be adapted to be pixel based. If we were to switch to a more of a grid when we just use pixels, and we're moving left and right on pixels, and then if you wanted to do now this isn't collision within other blocks. This is just collisions within the board. So there's still going to be some more collision detection that we do, because we're going to have to detect collisions with other blocks as we start sliding them down and into place. And once we start getting some of that logic in there, then we will be able to, we still need to work on rotating as well. And then after that, we can start putting multiple ones in there and having them drop down and start really building out the puzzle. And then we can build out the AI that has, once it detects that a row is all full, then it'll clear that row out and drop everything down. So there's still some stuff to do. There's plenty of work on this, and this has been a really fun series, and I hope you guys are enjoying it. I should hopefully have comments or something like that on the blog soon. If not, hit me up in Slack if you're a Thinkful student, or I will try to post something. I'm going to try to post something on there where you can just give me some sort of feedback for the moment, until I get true comments actually working. I'm trying to get it so that you can log into my blog just using your GitHub credentials, just using their OpenAuth web service stuff, and then that way you don't have to create an account with me or anything like that. You just log in, and then you can leave comments and I can respond. And there is a subscription box on there. If you want to get alerted of new videos coming out, please click the subscription box. And yeah, it's been a lot of fun, and I will see you guys next time.